highlighter here, we have two things to do in this question. We have to determine the non-permissible values, and we have to prove the identities. We're actually going to do the green part first. We're going to prove them first, and then we're going to use the proof to help us identify non-permissible values. So again, how do we set up a proof? We rewrite the question formality-wise, draw the line. And I would say, based on what we did last class, we now have two main strategies. One main strategy is change everything to sine theta and cos theta and simplify as a single fraction. But then we saw in our last proof, remember this one, where I just changed everything to cotangent and it made it so much faster? So if you can change everything to the same thing, that's also a very good strategy. Right, because this was the proof with sine theta and cos theta, quite a bit longer than just changing everything to cotangent. So when we start a proof, part of starting a proof is just taking a moment to sort of look at it, bring it all in. Like, could I change everything to one thing? Doesn't look like it in this case. And if it doesn't look like that, then maybe I would say, well, then I'll go to the regular strategy of changing things to sine and cosine. If I did that, that tells me I should change my cotangent to cos theta over sine theta. Make a big, thicker line, because this is my main fraction line here, right? And then cosecant is 1 over sine theta. And cos theta is already cos theta. No problem. Next, a fraction divided by a fraction. I do have a single fraction on the top and a single fraction on the bottom. If you have a single fraction on the top and a single fraction on the bottom, you can multiply by the reciprocal. Top fraction stays the same, the bottom fraction flips. And in this case now, we're multiplying. And these things are identical. Our proof is done. Now for A, I said we prove it first and then do the non-permissible values. And here I'm going to take out my highlighter. In mathematics, you are not allowed to divide by 0. We need to check everywhere in this question where we're dividing. I'm dividing by sine theta there. I'm dividing by sine theta there. I'm dividing by sine theta there. Can you see on the bottom of the fractions, the only thing that appears is sine theta. So for our non-permissible values, we would say that we know this sine theta cannot equal 0. Because if that green highlighted part is ever equal to 0, I'm going to divide by 0. But this still hasn't said the non-permissible values. The non-permissible values are telling us what theta can't equal. Think of your pie plate. Sine is x or y coordinate. Y coordinate. When is your y coordinate 0? Here, here, here. Right? Here and here. So how do I write that? Okay. Did it give me a domain for my? No. So it can't equal 0, pi, 2 pi, dot, dot, dot. Also in the negative direction, dot, dot, dot. Can you see how I could write all of those together as k pi? Where k is an integer. So that part is our non-permissible value. We can't divide by 0. We have to check where does it divide by 0 when sine theta equals 0 and we can either write it this way, or if you wanted to, right, what I'm basically doing here is writing a general solution, right? Those are my answers between 0 and 2 pi. It would not be wrong if you did, like, it would be redundant, but not wrong to write it as a general solution to all three of them. I hope you can see the first and the last one are identical, so it really is redundant. But when we write a general solution, we found all of our solutions between 0 and 2 pi and added 2k pi to all of them. K pi includes all three of those. But that would also have been a way to write your answer. Think of the general solution where we solve between 0 and 2 pi first, and then add 2k pi to all of them. Our next group. Again, write out the question, draw the line. Analyze it for a little bit first. Should I change to sine and cos? Should I get everything the same? Actually, both. Can you see that you can change secant to cos? And then everything is in cos. Which is like changing to sine and cos, but we just happen to have everything in cos. So the only thing I would have here is 1 plus cos theta over 1 plus 1 over cos theta. Fractions inside of fractions. We need to get a single fraction in our numerator and our single fraction in our denominator. In our denominator, can you see this is not a single fraction right now? I would need to get a common denominator, so I would multiply this one by cos theta over cos theta. Be very careful you don't get E3 errors. You are never allowed to write cos without a theta. It means nothing without the angle. But students sometimes just, I'll just write cos and cos. Without the theta is an E3 error if you forget a theta once, anywhere in a proof. Even if in the bottom corner you write this. Tan sine of cos, without the thetas. They look in the bottom corner and say, oh, we have to take off an E3. Because somewhere you forgot a theta. So be careful with that. The top. So can you see that if I did this? Here's my main fraction line, make it nice and long, nice and thick. On the bottom, I would now have cos of theta plus 1 over cos of theta, a single fraction. Is the top a single fraction? Technically, yes. Because what's the denominator of 1? What? What's the denominator of cos? 1. Do they have the same denominator? If you wanted to write them as a fraction over 1, could you? Yes. But you wouldn't have to, but just to realize the top is already, for all intents and purposes, a single fraction. And once we have a single fraction divided by a single fraction, oh, I've already got the word here. Erase it, do it again. I can multiply by the reciprocal, so my top fraction stays the same. Multiply, my bottom fraction gets flipped. We can only cancel out things if the factors are identical. Anything that's added or subtracted, sometimes students like to add brackets, say, hey, that's grouped together. Do I have anything identical? Yes, 1 plus cos theta is exactly the same as cos theta plus 1. All that's left is cos theta. Is that what was the other side? I hope so. It is. So we can say left side. Our proof is done. Now, switch colors. I want to look for non-permissible values. Take out my highlighter. I I'm going to highlight any place that I divide. Cosine. Here I'm divided by cosine. Are you okay if I don't highlight the 1? Because it's never equal to 0. Ooh, but here I'm dividing by cos theta plus 1. This is different than our first example. Our first example, we highlighted everywhere. We only had sine theta. But this time, we have a cos theta, and we also have a cos theta equals 1. So we have two things. We can say that, we know that cos of theta can't equal 0. We also know that cos of theta can't equal negative 1, because that would be bad. Is cos of theta ever 0? It's your x-coordinate. Pi over 2 and 3 pi over 2. So we could say theta can't equal pi over 2 and 3 pi over 2. And here, negative 1 happens right here. Cos of theta can't equal pi. If we wanted to write the general solution for the non-permissible values, pi over 2, 3 pi over 2, and pi plus 2k pi plus 2k pi. This would be all the non-permissible values. Technically, you could put the pi over 2 and 3 pi over 2 are exactly opposite of each other. They could have been put together as pi over 2 plus k pi. It's just jumping halfway around. But it's not wrong if you have it list all of them and add 2k pi to all of them. So we're sort of doing a general solution for the non-permissible values. All of these ideas start to intertwine, right? Coterminal angles, general solution. Now we're doing non-permissible values. They sort of have the general solution part built into them as well. Okay, so questions you can circle are 4, 8II, 9II, and